Climate 101, as Nancy said, there's so much information, and they said, oh, educate us on climate change in 45 minutes. And that's a challenge. So I will try to do the best I can, and there's so much more to learn than what we'll talk about today. So climate is to weather as the tide is to the surf. If you're down at the beach and watch the waves come in and the waves go out, you don't know if the tide is rising or falling, as with weather. If you watch the weather go warm, the weather go cold, you don't know if the climate is warming or cooling. So you need a long record. That shouldn't be a surprise to you, but just in case, it's very important to remember that this is not weather we're talking about. The fundamental is the greenhouse effect, which has been known about for quite a while, but we didn't really realize the magnitude of it until the last 20 years probably. So some sunlight is reflected back to space, some goes down and warms the earth, and greenhouse gases, CO2 and other gases, trap the heat. They essentially radiate it back down. Called the greenhouse effect because just like in a greenhouse where the heat is reflected back off the glass and keeps it super warm. What are greenhouse gases? Greenhouse gases are not all alike. This plot is from the Intergovernmental Panel on Climate Change 2007 report, the fourth assessment, which was, in my view, when the science was absolutely undisputable that this is a problem. It's a fancy term on the bottom named radiative forcing, which just means how much warming each of the gases have. The concentration of CO2 has about twice as much warming as these other greenhouse gases, methane, nitrous oxide, and HFC, which is hydrofluorocarbon, and there's more to it than that. It's just lumped. Let's look at those gases. So this is the gas on the left column: carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Couple of things to note. The global warming potential for carbon dioxide is arbitrarily taken as 1. The global warming potential of methane is 21, nitrous oxide 310. But look at these critters. We're in the thousands. And these stay in the atmosphere. Carbon dioxide, 50 to 200 years, think centuries. Methane oxidizes to CO2 and it goes away after a decade or so. Nitrous oxide, similar in that it's, in the century level, but look at these critters. They stay there think about 3,000 years ago. So greenhouse gases are abbreviated GHG. You will see GHG as a term. And the high global warming potential gases are these down here, and they are very worrisome. CO2 equivalent is essentially how much warming each one has as if it were CO2. You can see the huge difference of the warming potential. This is 18 ppm in the atmosphere, and yet it has this huge warming potential. This is 0.3, and yet it has a huge warming potential. These are very fractional even, but they have a big warming potential. So we need to be aware of hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. So this is the bottom line. It's getting warmer. These data from NOAA, the 0 line is an average of these central years. So before it was cooler, now it's getting warmer, inexorably getting warmer. And the thing about the CO2 is this is today, over on the right side, but it's increasing. We've had the Paris Climate Agreement, we've had Kyoto, we've had all sorts of promises, all sorts of thises and that's, and it just hasn't slowed a bit. So that's part of the urgency. Okay, computer. There we go. These are pictures, and it only goes to 2012, but trust me, it continues into 2021. So if you're looking at the blue colors are below the average around 1950. which was that central part on the graph previously. In 1950, we had some warmer, some cooler. By 95, it's really warming up. 2012, it's warming up even more. And
Wow.
a thing to notice, and it continues this way, a thing to notice is the Arctic is warming faster than the rest of the globe. And that's really important. Remember that when we get to a little later in the talk. This I found as a really compelling picture how different the summers are. When some of us were kids and some of us, were older than kids, this was the natural, this is the curve. This is warmer or hot, so-called normal, and cooler. But now most of the summers are hot or extremely hot. Very few are cooler. So there it is, it's warming up. So now we're going to do a little science, which I think is incredibly compelling. These are data from ice cores taken in the thick part of Antarctica, the Vostok area, which is in the eastern Antarctica. The ice cores look like this, and this is one of us geologists sorts looking at the ice core. The data are from present to 800,000 years ago. So moving up in time from the right to the left. Interestingly, Homo sapiens have only been around for 200,000 to 300,000 years. So this is including back in the Neanderthal and Homo habilis and before we were even a species. You'll notice the jagged lines. This is methane in parts per billion. This is temperature, and this is CO2. And you'll see the correlation, peaks, high peak, and the troughs correlate. My computer's not behaving. So if we look at the temperature of 0, that's the 1950 average 0. You can see that these temperatures for the peaks go up 4 degrees Celsius and or down, as you see, but we're going up. How much up? Today, CO2 is at 416. When I put this talk together, let's see, by about 4 weeks ago, it was 412. And I couldn't believe it when I looked again, it's 416. This about 4 years ago was 1800 and now it's 1850. We are way out of whack. So CO2 during this period, the highest CO2 got was 300 and it's 416 today. Methane was 800 and it's 1850 today. We are way out of whack. I think this is very important for people to understand. And if you remember the chart that showed these things stay in the atmosphere for centuries in the case of CO2, decades to centuries, the amount and rate of changes are unprecedented. In all of geologic time, they are unprecedented. And the resulting temperature to expect and the rate of change and so on is uncertain. And as many of you know, everything is affected by climate change. So you ask the question, wait a minute, we're at 416 and it's only about 1.2 degrees warming. Why? We have friendly oceans. The oceans absorb heat and they dissolve CO2. And they're continuing to do that. The reason there's a lot of ocean and it'll take a long time, on the order of thousands of years, 1,000 to 3,000 years, for the ocean to completely mix and we reach a steady state where the temperature will reflect the actual CO2. Also, this is an important one. Particulates and clouds provide direct shading and cloud formation. Let me show you what that looks like. Again, this is we already saw these CO2 and so forth up here. This is from the fourth summary. And radiative forcing, again, back down here, 0 to the right is warming, to the left is cooling. Solar irradiance is the only non-anthropogenic warming. And this is the net of all of these things. So you add that plus last, and so on, minus that, you get 1.67. But look at these blue guys. These are from total aerosols. That's tiny, tiny particulates. And so the direct effect is shading, like smoke. And the cloud effect is these particulates provide nuclei for clouds, which shade and reflect because they're white. And in fact, they reflect really well because the particulates, the aerosols, are so small that the clouds are whiter than typical rain clouds. So the thing about it is, so these things are warming and they stay around for centuries, and these stay around for weeks. So as we lose some of these particulates, you're going to see an additional effect. So these are 2017 CO2 emissions in the US. The most recent I could find, this is an EPA report in 2019. Transportation and electric power are the big two. Electric power is dropping in terms of emissions, thanks to some energetic, one can talk about why. There's a couple of reasons, but we'll get to that in a different talk. Industry, agriculture, commercial, and residential. This transportation uses petroleum to make liquid transportation fuels. Electric power, coal, and natural gas. Some of industry is, a lot of industry, in fact, is refining, so you could put that over in transportation. And these are predominantly, in terms of emissions, the emissions are methane and nitrous oxide from agriculture. Most of the nitrous oxide is agriculture, and most of these is natural gas. So coal, natural gas go to electricity, petroleum goes to transportation. This is a plot showing fossil fuel consumption, the US in the red line, and global in the orange line, and this is temperature, the blue. Fossil fuel consumption is really the dominant reason for it. Is the fossil fuel consumption is the reason that we're seeing the temperature increase. I love this picture. This is in China in 2010, a 9-day, 60-mile traffic jam. Can you imagine?
Ugh.
And it's growing. There's an insatiable thirst for liquid transportation fuels. The US already has, all of us have cars, 90%, whatever number we are. Developing countries are growing into this area. I have a lot of scientific evidence for human cause. We saw that graph showing that the radiative forcing from human causes are large and solar is tiny by comparison. Carbon isotope data and a number of other isotope data show that the additional CO2 is from fossil fuels. I have data on this at the end if anybody's interested. And unless you consider the human contribution, you can't account for the warming. And there's a whole lot of other evidence, just a whole lot. So I chose to knock this out of the presentation, and we'll provide it if you're interested. So what happens? We know some of them. Changing weather patterns, drought, we know about that. Stronger storms, we know about that. Wildfires, we know about that. Agricultural disruption. Farmers don't always know exactly when to plant. My cousin is an organic farmer in Montana. He runs his farm and ranch with wind turbine. And he was harvesting wheat in January this year, which is ridiculous. Harvest is in August. So it's very strange. Migrations, all of life conditions are modified. The biodiversity is changing. A lot of species are going extinct in 100 times more than in the, I don't remember from when, but extinctions are happening fast. It's a defense threat multiplier, and the Defense Department has been looking at this for decades and seeing it as a multiplier. The economy is changing. We're in the energy transition and societal changes. So the earlier comment, there was lots of environmental places that would take care of environmental, not anymore. We see this as a threat to democracy. And that's what we are. We're the League of Women Voters, and we see this as a very important part of the societal and government and economic changes. So some of the weather changes, hurricanes are increasing. This is Hurricane Sandy. These things cost money. The sea level was only 8 inches higher, 20 centimeters, and the additional storm damage shown in this dark blue and orange was $2 billion because of 8 inches of sea level rise, storm surge. That's a lot. This we're more familiar with. This is the map of where the fires were in 2020. That's enormous. It's 7,000 square miles. I mean, this is the actual map. It's big old blobs on our map of California. And the cost, $12 billion. And all of that, we spent $2 billion for fighting the fire, and there was $10 billion of damage to property. And a big kahuna in the Bay Area. Since y'all live in Marin area or Sonoma, you need to know a little more about sea level rise. There are two key drivers for sea level rise: thermal expansion. All plumbers know this, that when hot water takes up more space than cold water. And melting glaciers. Muir Glacier in Alaska in 1941. See how high it is on this hill? Now you don't. It's way down there.
Wow.
So it was this thick, and now it's gone. So that's ocean data are warming. I apologize for that. It's my attendance phone. So oceans, just one second. Okay, thank you. This is data. The oceans are in fact warming, and that's why that's most of the cause of sea level rise to date. And the ice sheets are melting. The Greenland and Antarctica are the two giant ice sheets. We saw an alpine glacier in Alaska, but these are huge. And you can see the decline in ice mass over time and where it's occurring around Greenland. Antarctica actually has some, the blue is actually increasing ice thickness, but this is a big problem, as I'll show you in a minute. Along the Antarctic Peninsula, West Antarctic Peninsula, and again, you can see the ice volume decreasing. So this is the peninsula, and the ice shelves, the glaciers come down and the ice floats on the ocean and serves as a deterrent in a mild way for the glaciers, but the on-land glaciers. But these are shelf collapses. So these are big, giant ice shelves, giant. But it doesn't matter if it's an ice shelf because it's floating on the water. So like ice in your drink, when you have ice in your drink, it doesn't overflow and the ice melts. In fact, it goes down a bit. So these don't add to sea level rise, but they are an indication of accelerating melting. The serious melting, though, is down in this area of Antarctica, Western Antarctic Peninsula here. It's just, I always get confused because there is no north and south, really. Everything is north in Antarctica. But anyhow, down below in this diagram. And the area is home to the Pine Island Glacier, and the Thwaites Glacier here. Look at the scale. This is 100 kilometers. We're looking at 50 to 60 kilometers, 30 miles across here. These have come ungrounded. So they were frozen to the bottom of the sea, and it was holding back the glacier. But they've come ungrounded, and the glaciologists say they are, quote, unstoppable. They alone could raise global sea level by 1.22 meters, and that's about 4 feet. I want to show you a time lapse, if you will, of the Pine Island Glacier. This is in 2009, and as we click through, it's about year to year. So this is 2009, and you'll see that the glacier's flowing. It's growing, coming out, growing, and growing, and growing, and breaks off, and growing, readjusting, and breaking off, and readjusting, and breaking off in 2017. So this is a picture of Pine Island Glacier, this one over here on the top of this diagram. And together, Pine Island and Thwaites drain about 5% of the Antarctic ice sheet. It's huge. And you can see it's melting. Global mean sea level rise is accelerating. These are the figures, 1.4, 3.3, accelerating. These are data, these are not models. And it's important to think about what happens in the Bay Area. This is our Bay Area. You guys live over here. And you know that the Delta is marshland and it's got levees and so on to protect so forth. And you know how it looks as you come up over Highway 37, it floods. The estimate from the Office of Planning and Research, the governor's office in California, is that we will be at 2 meters plus or minus 1 meter by 2100. 2 meters is about 7 feet. And so this is no meters. That one thing to notice is that as I said, there's levees that are protecting you in the Sacramento and San Joaquin Delta area. But they're just piles of dirt. They're not engineered. They're not like a dam. And so they are very...
It's our Dubs Insider from The Athletic, Marcus Thompson with Papa and
there we go. It's if you raise sea level and you have higher storms with higher runoff, the chance of breaking those levees is high. And if you break the levees with 1 meter of sea level, that's what it looks like. That's 1 meter. And that's 2 meters. So 2 meters plus or minus 1 meter. And for the Sonoma folks, look at where you are here. And you don't really have levees there, so it's going to just come right on up. The CHP office, of course, we talked to Mark Levine recently, and he said, oh, wow, the CHP office is like 2 feet above sea level. And part of the SMART train, Kiki will tell you, is vulnerable to sea level rise. So we talked about the glaciers, ice, land ice. This is sea ice. And so you think, oh, well, it's decreasing. March maximum, September minimum, it is decreasing. That's the old ice extent. But it's floating, so it can't be a problem, right? Wrong. Permafrost, with the loss of ice, you're losing the reflection called albedo. And it's warming. As you remember back in the early slide, we saw that the Arctic is warming twice as fast or more than the rest of the globe. And so the permafrost there is vulnerable. It's vulnerable with houses falling into it, but it's also these methane hydrates. Methane hydrates are a cage of ice, water ice, the red and white, and inside it is a methane molecule. There's also CO2 in the permafrost. This, by the way, is a picture of a methane hydrate burning. That's ice, and it's burning, so it's kind of cool. But we're looking down on the North Pole here, and all of the purple is permafrost. Once you start releasing this methane and CO2, you can't stop it. It's unstoppable. You can't go and it's just absolutely kind of terrifying, frankly, to me. But anyway, so if we were to melt all of this, it would be 3 degrees Celsius just from the permafrost. So what should we do? Terms you will hear are mitigation and adaptation. Mitigation is just reducing greenhouse gases. And you've seen that we've started doing it, but it'll take time to turn around. And you also saw CO2 hasn't slowed at all. So adaptation is really important. We're going to have to figure out how to live with it. But the change is happening. Wind is growing. This is an old chart. It's growing even faster than this. Solar is growing. Wind, by the way, is much more, is a much higher contributor to renewable energy than is solar. The challenge is huge, but so is the opportunity. And so we need to look at the opportunity of jobs, of change, of making the planet actually a nicer place if we have more green and so forth. But it's not going to be a nicer place for a while. The change is slow and it's urgent. This is California. All of our emissions from 1990, and our goal was to reach 1990 emissions level by 2020, and we did. You can see a lot of it is transportation. One thing that's a little frightening is this tan bit up here is agriculture, which is a net emitter. And we're trying to change that into a net sink. And we'll talk about that in a little bit. So we have to get down. This is all we've done. That's all we've done. And suddenly we say, okay, in the next 9 years, we're going to go to half. Serious stuff. It's urgent. It's very urgent. This is the CO2 curve we saw before. It's up here at 416. It stays in the atmosphere for 50 to 200 years. The safe zone is around 350. We're well above that. And it's going up. To keep temperatures down, we have to remove CO2 from the atmosphere, and that's called drawdown. And that's what we want our agriculture to start doing, is become a net sink or drawdown. So now that you understand some of those terms, this is the legislation that the League of California is currently looking at, Natural Resources Team. This is the climate legislation, and these are the bills. So all of this is adaptation. And hooray, hooray, sea level rise is for the first time in the legislature being addressed. Wildfire, no surprise, a whole lot of wildfire bills. And all of these bills are drawdown, looking how to use natural and working lands as a net sink. This is mitigation, trying to decrease fossil fuel use, and electrification. This is predominantly of buildings. So moving away from natural gas in the buildings to electricity. And of course, with the renewable portfolio standard, for those of you who know, that's the sources we use for electricity, and we have a very aggressive renewable portfolio standard. We want to be 100% zero carbon by 2045. And so that you can use electricity and you're not actually getting electricity made from burning of coal. So it's clean. So that's the legislation. The League is very, very active in climate change. We have the Climate Change Task Force in California. Everybody's welcome. And we have the US Climate Team nationally with 11 sub-teams. And that's just started in 2020, June, end of June, when we had the convention, and climate change was agreed. We passed as a membership that climate change is indeed a priority, making democracy work and climate change. And so now we're off and running. So that's a very quick overview, and you can ask questions. Hello.
Hi, Diz. This is Nancy. Hi, everybody. I had some computer difficulties, so I had to run to another computer. So I'm using my phone for audio, but I think this will work okay, I hope. Now it's just, let me look in the chat here. Diz, thank you so much. A lot of information, everybody. New terminology, a lot of dots that need to be connected. And I just want to remind you that this is the first pass. Like so many things, you have to hear it multiple times before it clicks. So just be patient with yourselves and take in what you can and don't worry about what you can't. This is a process for sure. I'm looking in the chat and I don't see any questions. Oh, here, Susan Stomp. Has the league developed any positions yet, Biz?
Yes, we have a climate change. It's called an action policy. And if I could, let's see, how do I do this? Just a second here. I'm going to share my screen again and show you the website. Just a second while I get it up. Oopsie. Hold on, we can do this. Okay, so this is the League of California website, climate change. We've had a number of forums. We used to get together like this, you know, not anymore. Anyhow, we've had in Northern California, Southern California, Middle California forums on climate change, and we have the Climate Change Task Force. So this is the area that the counties which are part of the task force, and these are the active teams. The US climate is also here. Let me just go back to show you the position. This is the climate change so-called action policy. This is from for California. And you can see the LWVUS positions and how they are also directly giving you a position on climate change. So it's on the website. You can look at it there and use it as much as you need. So it's based on LWVUS positions primarily. Action policy is when you put together a whole bunch of different positions and focus in on just one area. So this is climate change. Does that help?
Yeah, and also just to let everybody know, next month's meeting is going to focus on the league positions, both national and state, around climate change. We have 2 speakers lined up. Eleanor Ravel is from the US League, and along with Diz, they co-chair the US climate team. And we're also going to have April Okenda, who is with the State Climate Change Task Force, of which Diz is also the head of. So Eleanor and April will be with us next month to talk in detail about the national and state positions that address issues around climate change. So I hope you'll all plan to join us next month for that. Okay, back to questions. Let's see here. Lynn Dooley is asking, what can we do at home to help draw down?
Don't throw away your refrigerator. Refrigerants have the HFCs in them. And yes, the biggest thing you should do is don't fly, because that's a huge amount. And the second biggest thing you can do is have an electric vehicle, or don't travel at all. And then you can have move to electric in your home. You can have an induction stove, heat pumps for heat. Those all cost money. And one of the challenges with the league, from a league perspective, is we care about everybody. And so climate justice is a very important piece. So when in the building electrification, we want to make sure that it's equitable and people that can't afford it are not left behind. So that's one of our challenges. But you know, you have seen the urgency. We are way past the time when a bunch of people getting solar panels is going to make a difference. We have to have an all-out effort. You need to vote. You need to be a part of the constituency that changes the opinion of our electeds. We need to be active in larger and larger groups. So please join in the climate effort that the League is having. We are hearing repeatedly that we listen to you. I mean, we hear 350org and the Sierra Club, and we know what they're going to say, but we look at it from a broader perspective, and we get a lot more, we have a lot more gravitas, I would say, in how we're looked at. So we do have a voice, and we need to use it. So yes, work on things at home by all means, do all that you can, but that's not going to be enough.
Thank you, Diz. So our next question is from Sharon Seifert. Is the dairy farming community in Marin County actively involved in climate change projects? And I guess I can address this. Diz, I'm not sure if you're familiar, but yes, the answer is absolutely. There's a project that started some years ago called the Marin Carbon Project, which was being run out of Davis. And that project, I believe, continues. It has grown. It is looking at using compost spread along farming lands to sequester carbon. And that's moving along. There's a whole organization and people working around the sequestration of carbon in farmlands in Marin County. They're kind of in the front on that. On a more specific basis, I don't know if any of you have ever been to Strauss Dairy Farm, but Albert Strauss is way ahead of the curve in regards to what he is doing to reduce emissions from the cows, to the degree that they capture the methane that is put out by the cow manure, and they power the farm in West Marin completely with electricity generated from the methane from the cow manure. They also use that same power to charge their electric truck and other vehicles, electric vehicles that they have. So the short answer is yes, there's a lot being done, and we will talk more about that in the weeks to come when we start to really focus in on what is Marin doing specifically. So again, stay tuned. Kate Powers. Now, Kate, your message got a little cut off here. It says, wait a minute. Oh, there it is. I have read that 70 to 80% of greenhouse gas emissions come from cities. How will state legislation impact city decision making?
That's a really good question, because local authorities are very protective of their voice. And the state, as you know, California is an incredibly diverse state. And so I don't know about that 80% from cities. I don't know that statistic. Transportation is a big one, and buildings are a big one, so it makes sense. But the planning of cities is done by cities, and that's one of the things that is a challenge. So your guy, Mark Levine, has a bill this session, AB 1445, which is looking at housing, and that in planning where the housing goes, it's required that local authorities or regional authorities look at evacuation routes and threats from wildfire and sea level rise. So that's trying to put a state imperative on local planners. But there's also a number of bills that are regional plans for adaptation, where we're putting together, what you do in the Bay Area is different from what you do in Mendocino County, which has, steep coast. And so how that's going to work out with state mandated changes to local planning is a challenge. But regional planning is getting more and more recognizing that we need more and more of that, and to share the best practices among regions.
Great, thank you. A few of you are asking about the links to the Climate Change Task Force and the U.S. climate team. I don't have them available right now with my computer issues, but we will be sending a follow-up email to everybody who came to today's meeting with that information. So just stay tuned for a follow-up email. And also, we are recording this presentation, and it will be available on our YouTube channel and through our website. So that follow-up email will also give you directions when that's been posted to let you know that it's there for you to watch whenever you choose, and to direct other people there too. Linda Sula is asking, what are your thoughts on private jet owners trading for carbon credits?
Carbon credits are called offsets, so that you offset with something that takes CO2 out of the atmosphere and sequesters it. You can get money for that, and it's called an offset, or and sometimes called a credit. I personally think that if you look at carbon footprint by salary or by wealth or by whatever, rich people have a huge carbon footprint. So, using your private jet at all is, well, there's 2 people or 3 people in a jet. And so I personally think that that's kind of extravagant, but the idea of buying offsets is good. It's very important that the offsets are audited so that we know for sure that what is the carbon sink that is being purchased, if you will, is real. So that if they say, if it's we're not going to cut down this forest, and that's an offset, well, did they ever have a plan to cut down the forest? Or is this not changing anything? So
No.
auditing of offsets is important. You saw that drawdown, we absolutely must do drawdown. There's no way we can continue like we are. And an offset puts a price on drawdown so that you can actually make money by changing to something that is a carbon sink. So having offsets is a good idea. They're tricky because you need to audit them, but I think that we can get to a place where that's doable because they are so necessary. And private jets, not so much. That's my opinion, not the lead.
So Dan, I've read that for Tesla, as an example, Elon Musk actually makes more money selling carbon credits than he does doing the cars. Have you heard anything to that effect?
I don't know that data.
Okay, so
And
anyway, it's something
I don't see anything wrong with that.
not in the short term, but that's not the answer in the long term, don't you think?
Oh,
Having offsets, it just means the meter.
well, we're going to have to draw down. You saw the CO2 curve. It's going up, 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 up. The amount of drawdown we're doing is like a tiny, tiny fraction of how much we're putting in every year.
Yeah.
So we're going to have a vibrant market for offsets for a long time. So
Yeah.
I don't know about short term, long term. I would say I think we're in for it for a while.
When I say short term, I mean it's long, but in the long term. Okay.
Well, that's like
also,
a price. Sorry.
The key initiative here in Marin is called Drawdown Marin. And again, in the weeks to come, we are going to have a speaker come in who is involved very deeply with Drawdown Marin, so that again, when we're looking at what's going on in Marin, you're going to find out all those details in the months to come. We're trying to, speed this to you a little at a time. Mm-hmm. Our next question is from Barbara Strong. Does the California League address the issue of electrifying public transportation, not just encouraging electric car ownership?
Yeah, we have a transportation team. Virginia Wexman of LA is the chair of that team. And absolutely, electrification of everything is, we absolutely want electrification of everything, not just cars. In fact, we need to get rid of cars because the vehicle miles traveled is a problem. There's so much carbon emission associated with making the steel, making the parts, manufacturing, the asphalt on the highways, the concrete on the highways, the et cetera, et cetera. Just a vehicle is a high carbon emission, even if it's electric. So yeah, public transportation is pretty important, and everything has to be electric.
Right. And also we have an entry here from Lynn Spittler, just that she heard this morning on NPR that Amazon and the Postal Service and others are going to electric delivery vehicles.
Yes.
So that's good to hear.
Mm-hmm.
Let's see, we're gonna have to, we've got time for 2 more questions. So real quick here, Diz. Oh, well, can you recommend any library books specific to California and climate change issues that would help give me some education and background before jumping into an active volunteer role? Wow, there are so many books.
Yeah, not one. I would start with the state website. Go to the, you can just put California government climate change in your search engine, and you'll probably get to the California Air Resources Board, which is responsible for most of it. And they have a lot of information California specific. It's very readable. And so I would, I'm sorry, it's not a library book, it's on the online, but it's very useful and very well vetted.
Okay. That follow-up email will include that website link among others. And Ingrid, we can also give you some books to start out with. There are so many books and there are new books coming out every day. And eventually we want to have a place where you can go on our website where you can look for lists of resources to learn more. So yes, there's tons out there. Kiki Laporta says, thanks a million, Diz. And what are the biggest bang things the League can do to support right now? What about the legislation?
The biggest thing you can do is talk to your legislator. So that we just did legislative interviews. One of the questions was on drawdown. And the constituent, you know, California is a little different in that we have a very aware state government about climate change. So, and our senators are very aware also. But voting is super important, and changing the constituency's opinion is super important. So education, events, things like that are big hits. We will, as the State League supports different bills, we have a legislation website as well. It's climate change. If you go to the climate change page, I went down to the bottom, found the task force. There's also a link to climate change legislation. And you can see what we are supporting and what not. So the biggest bang for the buck, I think, is informing voters from a League perspective and on climate change. But the other thing that's really important is that we are balanced. We are nonpartisan. Let's listen to the right wing and try to understand, look for common ground. So preaching to the choir really doesn't do a lot. You know, people who are typically go to these events are people that already think climate change is a big deal. And getting ourselves educated that way is fine, but then we have to reach out beyond that. So reaching the whole, reaching a balance, finding common ground as the League, I think is a big hitter. And that's one of our key areas of focus for the national effort.
Thank you, Diz. So we're going to close the Q&A session. I'll just also draw your attention in the chat. Scott has entered a link where you can see more about the positions of the League on climate change. So the link is right there in the chat. And this is going to stick around because we have a couple more things to talk about. But meanwhile, Linda, do you want to jump in?
Yes. Diz, thank you so much. It was, I don't want to say overwhelming, but it was whelming. And I appreciate how you tried to pare it down to having me understand it a little bit more. So thank you very much. And Nancy already covered the part about our next meeting. We hope you all will join us. They'll be introducing us to the league positions that relate to climate change issues. You can expect a detailed email with more information next week, along with the Zoom link to register.